So in question 3, we are given this diagram. We have this block X on top of block Y, and we are asked to find the minimum force of F required to move block Y just before block Y begins to move, and we also need to state the tension in the string at this point. So what we need to notice here is that, well, firstly, there's friction in between both surfaces, and when the block Y is about to move, block X is still stationary, and the tension force that is acting over here must balance out with it must cancel out with the frictional force acting on X at the surface of X and Y. So we can already calculate that the maximum tensional force that we can have is going to be equal to the frictional force at the surface of X. So that will simply be the coefficient times its weight. So that will be 2 newtons. So the tension in the string can at most be 2 newtons. And then we can calculate the force F required to move Y. So this force F will have to work against two forces. There will be a frictional force pulling Y back at the ground, and there will also be the force pair of this frictional force on X. So there's a force on Y acting from X. So there's going to be two frictional forces, and that frictional force will of course be equal to this force, as they're the same magnitude, just opposite directions, as stated by Newton's third law. So what we can say is that the frictional force at the ground between Y is going to be the total weight of the system, as the normal force here is going to be the weight of this plus the weight of this. So that will be 30 times 0.2. And then we add this frictional force that's pulling X back. So if we do this, we get 8 newtons. So the minimum force is 8 newtons, and so the answer is A.